Today's lesson is 2.2 and the focus is going to be on corresponding angles. There will be other terms in today, but it's generally a short day. So congruent is the first term we're going to get to, and that'll be useful in terms of corresponding later. But congruent means same shape, same size. So pretty short definition. And then we're going to have a symbol for that, which is an equal with a squiggle on top. So there is a difference between congruent and equal. I think it takes a little bit of time for students to really understand what that is. Congruent means the things, so I like to look at it kind of like the things are the same. And then equal, so I'm going to kind of put it down here separate. Equal is talking about numerical values, numbers. So congruent is saying like, hey, this shape is the same shape and size as this other shape. So like this square is the same shape and size as this other square. But when I say equal, I'm talking like the perimeters are equal or the areas are equal. So you can talk about numbers, which would be equal, or you can talk about things, pieces, parts, and that's congruent. Yes, things that are equal would also be congruent, but like they can't interweave. So I can't say that this distance is congruent to this distance. I would say this distance is equal to this distance. Numbers have to stay with equal sign, and then things have to stay with congruent. And you'll see that in this next part. So yes, this next part is kind of repeating some of the stuff I said, but I think it's useful when learning about congruent for the first time, what is going on and hearing it a couple times. So it says angles are not the only type of figure that can be congruent. For example, one side of a figure can be congruent to another. Also, a complex shape, such as a trapezoid, can be congruent to another if there is a sequence of rigid transformations that carry it onto the other. So like reflection, rotation, translation, all of those things are going to keep the same shape and size. It's just going to move it somewhere else. Consider an isosceles triangle, like the one shown to the right. Because of its reflection symmetry, which parts must be congruent, see each relationship using symbols. So just real quick, what we would have done before for equal, just as a reference, is we would say this is equal to this. So AB equals CB. So without saying it in words, I am telling you that AB is the same numerical value as CB. So then, if I want to talk about congruent, so we'll do all the congruent stuff. You're going to use different symbols. Remember this symbol to represent same shape and size versus just the equal size. I don't want to say the numerical value for AB is the same as the numerical value for CB. I want to say the thing. So to be able to say the thing, well, AB is a segment. So I'm going to write AB, but put a line over it to represent that segment. Is congruent to CB. So you see how these are different, and they have to be that way. You can't be mixing symbols. So if I put a congruent sign, I have to have the segment lines above it, like this right here. If I don't have the congruent symbol, I just have equals, there's no lines above it. Okay, so then some other things. How are we going to talk about the other segments? So these ones down here, I can write DA is congruent to DC. And notice how I'm picking the same letter, or sorry, I'm picking the same location to correspond to the other one. So like D went first here, so D is going to go first here, and then it goes out to A and out to C. So I'm trying to keep it in order, and that helps with the reader to understand what's supposed to go together. So then I also know, if that's a line of symmetry, that angle A is congruent to angle C. So previously we would have written measure of angle A equals the measure of angle C, because measure means a numerical value. But then if I'm talking about just the things, I want to say angle A, just that thing, which would be an angle, is congruent to angle C. So for me to look at it, if you were writing the measure of angle A is congruent to the measure of angle C, I would know that's incorrect because you're trying to tell me the numerical value of A is the same shape and size as the numerical value of C. You can't tell me that numbers are the same shape and size because numbers aren't a shape. So the next one, let's talk about this last set of angles here, and I'm going to use two curves to represent that it's the next thing that's different. Angle A, here I'll run over it, A, B, D. How you feeling about that cursor? It took me a little while to figure out it's congruent to angle C, B, D. And then we could talk about the middles, but I'm not going to. We'll address that more later. Okay, so now that we have congruent, we're going to go to another term, which has no relation to this, but it will all make sense at some point soon. So transversal. Transversal is a line that intersects two or more lines. Now, in this course, we're going to be using it in a very specific way, but it could represent a lot of different pictures and situations as long as it's just intersecting two or more lines. So if I give you an example here, this line in the middle hits 1, 2 lines, so that would be considered the transversal. So this right here, this highlighted thing, is my transversal. Okay, so now we're going to kind of pull all that stuff together in a second. Last new word of the day, corresponding angles. So corresponding angles are angles in the same position at different intersections. Now, an intersection would be like at a traffic light. So this is an intersection, and then you have different angles here, 1, 2, 3, 4. You can label them however you want, but that would be considered an intersection. So I'm going to use highlighter here to represent the corresponding angles in this picture below. So 1 is on the top left of its intersection right here, and then if I go down to the intersection down here, the one that is the same position at the different intersection would also be the top left one. So the top left would be right here. So 1 top left, 1 and 5 are considered corresponding. So angle 1 and angle 5 are corresponding. And then what about the top right? Let's do a different color here. Top right is 2 and top right is 6. So I'm going to say angle 2 and angle 6. So these are pairs that are corresponding. And then let's do a new color. Let's do yellow. 4 and 8. Angle 4 and angle 8. Those are bottom right of their intersections. And then let's do the last set. Let's do green. 3 and 7. Angle 3 and angle 7. Those are all corresponding angles. What can we learn about corresponding angles? So if I look at this picture right here, 135 is at the top left and X is at the top left, so those are corresponding. I'm going to trace this angle and I'm going to move it over and see if there's any relationship. It fits perfectly on top of there, so what that tells me is that X is also 135. And then X and Y are vertical, so we know that Y is 135. So we're going to keep in mind that we found that X is 135 and Y is 135. Now in the next picture to the right, we're going to do the same process. Let's look at which two are going to be considered corresponding. So 135 is in the top left and x is in the top left. So let's see if there's a real special relationship there. Trace 135 and then move it down and it fits perfectly. So x is 135. And then y and x create a straight line. So I'm going to write 135 plus y equals 180. And then I'm going to solve for y. So y equals 45. I'm going to write that up here. Okay, so I've got answers for those. Now let's go down here. So looking at this picture, 135 is on the top left and x here is on the top left, so those are corresponding. I'm going to trace 135 and move it over. Oh, but it doesn't fit. So x is not 135. Well, what about y? Y and 135 create a straight line, so I can say 135 plus y equals 180. So y equals 45. So I can't find x right now. It's not possible at the moment. All right, what about here? Looking at the last one. Same situation. I'm going to trace this. If I move it down, it's not completely on top of it, so I actually can't find this little guy here, which would have helped me find this, and I can't. So then I do x plus 135. Gets me 180 again. I know straight lines, blah, blah, blah. Well, in all of these, I was able to do the straight lines for every single one of them, or vertical angles on the first one. But why is it that in these two, I could find the corresponding angles, but not in these two? What is different about those two pictures in the first two? What's special about them, but not in the second two? What's special is that the lines are parallel. If you see these arrows, and then here, if you were to extend these lines, they would cross. So that means they're not parallel. So if lines are parallel, then what happens to the corresponding angles? Let's look at them again. If lines are parallel, we know that corresponding angles do this, and they do this. So if lines are parallel, then corresponding angles will always be equal to each other. So let's go down to our next one, and we're going to write it down. If parallel, then corresponding angles we said are equal, and I'm going to use congruent here because it's our new word. But if you write equal, it's not going to hurt anything. It's still true. So now in my picture, I'm going to highlight all the corresponding angles, but now I get to also say those are congruent. So angle 1 is congruent to angle 5, angle 2 and 6. This color coding is really useful. And then angle 4 and 8. It's useful and like super cute. And the last set, angle 3 and 7. Oop. But what is it that my picture, I just realized this, what is it my picture is missing that has to be there? It has to be there. You're like, Ms. Robinson, what are you doing? You're doing it wrong. I know, life is hard sometimes. It has to be parallel, so first of all, you would already have arrows on here. I just didn't have them on there. You need arrows inside there. So these arrows here, the set of arrows, tells me that the lines are parallel. They have to be parallel for things to be congruent. If we go back, if they're not parallel like here, they will not be congruent, not equal. Got to be parallel. So then, now that we know this information, how can we apply it? All right, so practice question here. We've got parallel lines. So we know if parallel and corresponding angles are congruent or equal. So this is my bottom right, and this is my bottom right. So those two things will be equal to each other. And in this case, we want to use equal instead of congruent because we're talking about numerical values. So we're going to put an equal sign in between. And now we can ignore the picture and just solve for x. So I wrote 3x plus 5 equals 4x minus 6. So I'm going to take away 3x from both sides. I get 5 equals x minus 6, and then add 6 to both sides. So x equals 11. And remember, there's situations where I could ask you to take that and plug it back in to one of these to find the missing angle. All right, good luck with your practice today.